All right, let's dive right into this explainer. Today, we're taking something that usually strikes fear into the hearts of, well, almost everyone, algebra, and we're totally reframing it. We are not looking at confusing, abstract math here. Instead, we're going to see algebra for what it truly is, a highly practical, surprisingly simple language that we actually use to solve everyday problems. We're pulling from this fantastic source material today, a lesson plan originally built for junior high schoolers in the Philippines, and it just brilliantly bridges that gap between those intimidating math symbols and our actual daily realities. We're talking budgeting, commuting, even running a small business. Look, if you're someone who literally breaks into a cold sweat just seeing a math problem, especially one with letters in it, you are completely normal. You are not alone. Our entire goal today, to shatter that anxiety completely.
So what does a letter like X or Y actually mean in math? What's really fascinating about this question is that it hits right at the core of our universal anxiety around mixing letters with numbers. For so many of us, the second the alphabet invades our math equations, we just freeze up. It feels like an unfair trick, right? Like, why on earth are there letters where numbers should be? But here's the thing. If we want to actually master algebra, we just have to rethink what those letters represent. Honestly, think of algebra exactly like learning a new language. You already know English, right? So we're simply translating it into a shorter, faster code. Those letters and symbols, they absolutely aren't there to confuse you. They're actually there to save you time and give you a universal shorthand.
Which brings us to Section 1, Math as a Foreign Language, and translating words into code.
Moving right along to Section 2, the core algebraic vocabulary. These are basically the building blocks of our new language.
Okay, so before we can start translating whole sentences, we obviously have to learn our core vocabulary. It's exactly like learning verbs and nouns in a new spoken language. Algebraic expressions are built from very specific, basic components. First up, the variable. A variable actually answers our initial question about letters. It's simply a placeholder for a number that can change depending on the situation. Think about it like this. If you're buying snacks, you might not know exactly how many you're going to buy yet. Maybe you're waiting to see how hungry your friends are, or maybe you're just checking how much cash you actually have on you. That unknown quantity, that is your variable. We typically use letters like X, Y, or N, but honestly, any letter works as that stand-in. It's really just holding the space until you're ready to make a final decision.
Now, the next vocabulary word we need is constant. And unlike a variable, a constant is a number that stays exactly the same. It provides a solid, unchanging anchor in our math sentences. For example, if a pencil costs 10 pesos, that 10 is a constant. It absolutely doesn't change whether you buy 1 pencil, 5 pencils, or 50 pencils. The price per item remains completely rigid. It's the fixed reality in your equation. No matter what else fluctuates or changes around it, that constant just stays put.
Finally, we have the coefficient. And this one brilliantly illustrates how numbers and letters interact to create that faster code we were talking about earlier. A coefficient is really just telling us how many of that variable we have. So when you see a number sitting right next to a letter, like the 8 in 8n, it means they're being multiplied together. That 8, that's our coefficient. It's the multiplier. And notice how there's no multiplication sign between them? Well, in algebra, placing a number and a letter side by side is our universal shorthand for multiply. It just keeps the whole equation looking clean and visually simple.
All right, on to Section 3, translating words into math, where we actually start applying this grammar. So this is where the actual translation happens, taking the English phrases we use every single day and shrinking them down. By identifying some specific clue words, we can instantly know exactly which mathematical operation to use. You can basically consider this your ultimate cheat sheet for algebraic grammar. For instance, the phrase increased by always points to addition. Less than, that's a huge trigger for subtraction. Product simply means we multiply, and quotient means we divide. It's really that straightforward. Once you internalize these triggers, the translation feels entirely automatic. It becomes like muscle memory. Let's practice a few real examples so you can see just how seamlessly this all works.
Let's start with addition. Notice how the phrase increased by translates perfectly into a simple addition sign, a plus. We literally just take our unknown variable, which we're calling x here, and we just add 3. So that slightly lengthy sentence, a number, x, increased by 3, shrinks down beautifully and super efficiently into just x plus 3. Easy, right? Now, pay very close attention to this next one, because less than means we are subtracting the 7 from our variable y. I have to point this out because this is a very common trap that trips up a lot of beginners. It is not 7 minus y. If you think about it in real life, if I say I have 7 less than you,
Well, we have to start with your amount first, the y, and then take 7 away from that. Because it's 7 less than the number, the variable y absolutely has to come first in our algebraic expression. So it correctly translates to y minus 7.
Okay, multiplication. When we hear the word product, it means multiply. And like we just learned with our vocabulary, in algebra, multiplication is often written cleanly by placing the coefficient right next to the variable. Honestly, you don't even need a little x for a multiplication sign anymore. In fact, scratch that. Using an x would get incredibly confusing when our variable is also x. So we just write 8n to mean 8 times n. Remember, the number, our coefficient, usually goes first.
And finally, the word quotient signals division, which completes our core grammar translation guide. We take our number x and we divide it by 2. Now you can totally write this with a standard division sign, but very often in algebra, it's just written as a fraction, x over 2. Just keep in mind both mean the exact same thing. Let's move to Section 4, Evaluating Algebraic Expressions, where we're finally putting the language to use.
Now that we actually know how to write the code, let's step into the real world and plug in some actual numbers. This process is called evaluating the expression. I want you to imagine you're walking up to a local sari store in Abu Yog Leyte, just jingling a few coins in your pocket. You're looking at these totally familiar baseline prices displayed at the counter. A pencil is 10 pesos, a piece of bread is 8 pesos, a notebook is 25 pesos. Remember our vocabulary? These are our constants. They are the fixed prices set by the store owner that absolutely will not change.
So, using our new vocabulary, we can create these 3 mathematical expressions to represent the total cost for any amount of pencils, notebooks, or bread we might want to buy. If we want pencils, it's 10 times x, or 10x. Notebooks are 25y, bread is 8b. The letters, our variables, are simply holding the space until we make a final decision on the quantity. The prices are our coefficients, which we'll be multiplying by however many items we end up needing. Let's actually see this in action. If we substitute the variable x with 4 pencils, we are evaluating the expression. We literally just swap the letter x for the number 4. We then multiply our constant price of 10 by our 4 pencils, and boom, we get a total cost of 40 pesos. The math is doing the heavy lifting for us here, seamlessly turning abstract ideas into exact, real-world budget calculations. Similarly, evaluating the cost of 3 notebooks proves how this sort of invisible math quickly solves our simple, everyday budgeting problems. We take our expression at 25y, we swap the y out for a 3, and we multiply. 25 times 3 gives us a total of 75 pesos. By mapping the real world to our algebraic expressions, we can accurately plan out our purchases before we even hand over a single peso.
Section 5. Solving real-life problems. Applying formulas to daily situations.
Now, it's one thing to calculate the cost of a few pencils, but how do we approach slightly more complex situations, like, say, calculating transport fare or tracking daily business income? Well, our source material outlines a pretty foolproof 6-step method for this. First, you read the problem carefully so you understand the context. Second, identify what is actually changing, because that is your variable. Third, write the formula using your constants and variables. Fourth, substitute your real numbers in where the letters are. Fifth, simply solve the actual math. And finally, step 6, explain what your answer actually means in the real world. Honestly, this methodical approach ensures you will never feel the lost in a word problem again.
Let's test our steps on computing transport fare. We'll start by reading the problem carefully to hunt down our constants and variables. Okay, so we know the cost is a fixed 15 pesos per ride. Since it's fixed, that amount is our constant. The number of rides, however, can change depending on how many people are traveling or how many trips you take, so that will be our variable. And in this scenario, we are being asked to evaluate the cost for exactly 6 rides.
Following our steps, we chose R to stand for the number of rides. That makes our formula 15R. We then substitute 6 for our variable R. 15 times 6 gives us 90. And the final step is explaining it all in context. The total tricycle fare for 6 rides is 90 pesos. It's incredibly satisfying to see a seemingly tricky word problem break down so cleanly, isn't it? We didn't panic when we saw the problem. We just followed the steps, translated the English to math, and let the code do the work.
And this exact, identical process works for tracking infram too. Let's say you're selling banana Q for 12 pesos each. Your formula is simply 12B. If you have a truly great day and sell 25 pieces, you just plug 25 in for B. 12 times 25 means you earned 300 pesos. Suddenly, algebra becomes this incredibly powerful tool for life and career skills. It literally empowers small business owners to forecast their days, project their earnings, and manage their inventory. It completely proves that this is absolutely not just some abstract classroom exercise destined to be forgotten after graduation. Everything we've just practiced culminates in this one core concept: building custom mathematical formulas that act as reliable rules for your daily life. A formula is simply an algebraic expression that represents a real-world reality. It's a tool that you can build yourself whenever you notice a pattern in your life of repeating costs, earnings, or measurements. It essentially hands you the keys to gaining control over your budget and your time.
So, we've seen how algebra is really just translating everyday English into a highly efficient, super practical code. The math is already there, working silently in the background of your daily life, whether you're buying snacks, riding a tricycle, or tracking your savings. The only question is, now that you finally have the language to read it, what secret formulas will you discover today?